Pick up a high-quality bamboo t-shirt, and you notice its extreme, silk-like softness. But that texture originates here, inside a rigid, towering grass. Mapping the path from a dense, wood-like biomass to a refined textile requires looking at the specific engineering steps that connect the forest to the factory floor. We can follow this journey using a 4-part framework, tracking the material as it moves through the forest, the pulping facility, the fabric mill, and the garment floor. Understanding these 4 phases provides a clear look at the material's physical evolution from a raw plant into a finished consumer good. Step 1 begins in the mature bamboo forests. Workers manually harvest thousands of stalks, selecting them based on growth cycles to ensure a high yield of usable cellulose. These yields of raw biomass are loaded onto heavy transport trucks and moved out of rural regions into centralized, modern factory complexes. Once inside the facility, the mechanical reduction begins. Industrial blades cut the long stalks into smaller sections, and massive crushers break those rigid pieces down into rough bamboo chips. These chips immediately enter a high-volume industrial wash. This tumbling process strips away soil and organic impurities from the raw material. This mechanical breakdown is a preparatory stage. It doesn't yield fabric yet, but it creates the surface area required for the chemical extraction in the next phase. Bamboo fabric isn't woven directly from dried grass fibers. Instead, the workflow mirrors industrial paper manufacturing. The washed chips move into large fats where a chemical and mechanical purification process dissolves the material. What remains is a thick, viscous liquid pulp. This layout shows the transition from the dense, wet liquid pulp on the left to the dry, fluffy white textile fibers on the right. To create fibers, the liquid pulp undergoes extrusion. It's forced under pressure through a spinneret, a metal plate with microscopic holes, solidifying into thin strands. This microperforation softens the cellulose, creating pliable strands ready for refinement into yarn. This step is a major transition point in the supply chain, as the material is no longer wood, but a workable textile fiber. Now that we have loose fibers, industrial spinning machines draft and twist them together. This binds the short fibers into a single, high-tension, continuous yarn. Miles of this yarn are fed into automated circular knitting looms. These machines interlock the threads to produce massive, continuous sheets of raw fabric. Those sheets move into wet processing, where the fabric undergoes an industrial wash to remove knitting oils before being submerged in eco-friendly dye baths. The dyed sheets are passed through heated dryers. At the exit, inspectors monitor the feed for snags, color inconsistencies, or weaving flaws. Once cleared, the continuous sheets are rolled into fabric bundles for internal transport to the assembly floor. The organic harvest has now been converted into a standardized commodity, ready for specialized construction. The fabric rolls are unspooled, and digital patterns for sleeves, collars, and torsos are mathematically nested on a grid to reduce waste. Automated cutters then slice through the layers. Floor workers now use high-speed industrial sewing machines to align the cut panels, punching through the layers to lock the seams together. Assembly is followed by quality checks. Inspectors trim loose threads, test the stitch strength, and use industrial steam irons to set the garment's final shape. Finishing applications follow, including the heat pressing of sizing logos and the attachment of care tags and brand labels. Finally, machines fold the t-shirts, place them into protective packaging, apply barcode labels, and stack the boxes onto warehouse pallets. These standardized cut and sew protocols are necessary to ensure uniform sizing and quality from a material that began as a wild grass. Looking back at our flowchart, all 4 stages are now complete. The manufacturing cycle is finished, and the boxed garments are loaded onto freight trucks. These trucks move the inventory out of the factory complex toward ports and distribution centers to fulfill retail orders. We followed the material from the initial harvest through pulping, spinning, knitting, and final garment assembly. By following this sequence from the forest floor to the warehouse, we can see the exact steps and the specialized engineering required to bring a bamboo t-shirt to the shelf.